Welcome back to our Introduction to SolidWorks video series. In this video I'm going to show you how to find a bunch of off-the-shelf parts and their models so that you don't have to recreate common items that you might use in your parts or assemblies. So as an example, I've opened the flange from Chapter 1 that we then modified in Chapter 5 to add some different configurations. So you remember it has different diameters, different number of bolt holes depending on which configuration we're in. So let's say now we're going to work on this and we want to create an assembly that has this flange part and then a series of bolts with a bolt that matches each of the holes in the flange here. So to do that, I could model out a socket head cap screw or a bolt if I wanted to. But for common parts like that, it's a lot faster to just get a model somebody's already made. So we're going to go through a couple sources for that. So Google's always our friend when we're trying to find new information. So here I'm at the cytomcmastercom. This is a kind of giant company that has all kinds of different hardware. And one of the great things about their system is that they have this huge catalog of hardware, but they also have models for almost all of the items they sell. So let's say we wanted to put some socket head screws in those. And I think those are 1/2-inch diameter holes. So I'm just going to click on socket head screws and I'll keep kind of clicking my way down through their menu. I'll just basically take the most basic option for each thing. And I'm going to say, I could scroll all the way down through here, but you can filter things off on the left. I'm going to say I want 1/2-inch threads. So let's use 1/2-inch 13. So coarse threads, that's going to filter down. And then how long do I want them? Let's say I want 1.5-inch bolts. So if I click on this one here, it brings up a little sub menu and it shows me some details about it. How much it would cost is $13 for a pack of 10. And you can see I could already, right now if I wanted to, I could download this SolidWorks part. And I might do that here in a minute. Let's go on to the page. So if I click on the product detail, you can see here, it shows me a rendering. It's a real good rendering, so it almost looks like a picture. Also shows me a drawing, and that looks pretty similar to some of the drawings we've created in SolidWorks. And if I keep scrolling down, here's a ton of information about it. It's surface finish, what it's coated with, etc. And if I'm looking over here on the left, I can see that these are the two different documents available. Up here, though, if I look under CAD, you can see there's a 3D SolidWorks. There's actually a bunch of different 3D formats I could download, but it remembers that I've been here before and that I like SolidWorks, so it's already got that selected for me. So I can just click on download, and it brings this part in, and I can just click on that part, and you can see there's my model of a socket head cap screw. It saved me a lot of time to create that part on my own. So now if I go back to my part, I wanted to create an assembly of it, so I can just go up to new, make assembly from part, and add in my P510 part. Okay, and then I insert component, just add in that alloy screw that I found. And there we go. And I can then take this screw, pick a circular surface on it, or a ring, make that concentric. And I'm already along the way. And we're going to look at making patterns out of parts in a video later on this week. So for now, I'm just going to leave that there as an example of how to get a part from McMaster-Carr. Let's go back and look at that website some more. Go back to McMaster-Carr. Another thing that we're going to show you later this week is how to use mechanical mates within SolidWorks. We've looked at our standard mates within an assembly. But mechanical mates are things like belts, gears, rack and pinion, screws, things like that. And we'll talk more about that, but let's go ahead and get a few gears while we're here. So I'm just going to search for gears. Okay, brought up a bunch of them. We'll just use metal gears. Let's get something big enough that it will show up in our model easy. So let's say So gears, we're not going to talk too much about gears as far as mechanical design because we're just practicing using them in SolidWorks. But gears are have specific dimensions that are important to use when you're setting up assemblies. And specifically, the pitch diameter is the thing that's most important when you're working with gears. If you look at this drawing here, you can see there's an outer diameter, but the pitch diameter, you can see that's that inner dashed line. That's the diameter at which the two gears actually would mate, where if we were going to make a coincident, we wouldn't make it with the outer edge of the gear, we'd make it with that pitch diameter. So let's go ahead and just download a couple that have easy, convenient pitch diameters. So maybe something like with a 2-inch and a 4-inch pitch diameter. So let's get this. Yeah, let's download this one here. And here I'm just going to go straight to downloading it. So that'll get me 40 tooth and then another one 20 tooth. Okay. Okay, so we've got our gears. Last thing, let's go back and get a gear rack. So again, we'll get one that matches the pitch of the last ones. Okay, so now if I open each of those, you'll see I've got a SolidWorks model of the gear rack. And if you look over here, this is a true SolidWorks model. If I look at the feature tree, it has extrudes, cuts, fillets. So basically I could go in and edit this if I wanted to. I don't want to, that's why I'm getting it off the shelf, so somebody's already done it. But I just want to show you the difference between getting something that's a native SolidWorks file versus if we go back and let's look at this same part in detail. If instead of getting a SolidWorks file, I downloaded, let's say, a step file. That's another really common kind of interchangeable 3D format. So it's not SolidWorks specific. When I download it, you can see SolidWorks recognizes it. It puts the icon type as being SolidWorks, but the tail end of the name there is .stp instead of .sldprt. So let's go ahead and open that. You can see it's taken a little longer because it's kind of converting as it goes along. And here, if you look at the part, it looks identical, but over here you can see that our icon looks differently. This is an imported part, and if I expand on it, it's just a solid body. There's no extrude, there's nothing that I can edit really. It's just one solid body. So it's still useful. If it would be maybe better than nothing if I wanted to use this exact part, but it's not something that I can edit and conveniently turn into a different SolidWorks part. There are ways you can ask SolidWorks to go in and try to recognize features from just a solid body like this, but we're not going to get into that today. So that's just a little information saying, kind of highlighting that you can download in all kinds of different 3D formats, but it's always easiest if you can get it in a native SolidWorks format. Okay, let's just go back quickly. So McMaster-Carr, anytime you're working on mechanical things, that's a great source. But a lot of times you're working with parts that are specified by somebody else. So for example, I might be working on a hydraulic system or a pneumatic system, and I need to get some couplers or even some valves. So Parker, for example, is a company that makes a bunch of different types of fittings. So if I needed a air fitting, I could go to Parker's website, and here you can see I've already found a particular one. This is their family of pneumatic quick connect fittings, and I can just scroll down here. There's a whole bunch of them, the coupling side, the female side, or if I need the plug side, I could go to one of these, and here they have a CAD as well. And so if I go look at the CAD viewer, you can see this is a preview just within their system of what the part would be like. And I can say what format do I want. And again, I can pick, looks like this one they have, yeah, I don't want that one, so I'm going to look for different format. Okay, so you can see as I was typing there, it was showing it, but I went too far. So SolidWorks, newer than 2006. Yep, that's the one I want. Okay, and that's good. And go to Files, Generate Files. And now it's creating a model, and their website takes a little longer because rather than having all of the files pre-ready to go. They create the file for me when I ask for it. So it's ready now. I can click on download. This one is a zip file, so a little bit, I have to unzip it a little bit to get to it. But then once I'm there, I can open the part. And so here's an example where it came in as a SolidWorks part, but it is in the SolidWorks part, it was just a solid body. So if I want to actually try to turn that into features, it's saying, hey, it recognizes it doesn't have any features. Do I want to try to have SolidWorks recognize some? And so I can say yes. And now it'll go in and try to figure out how could SolidWorks have created this part, and as far as a series of steps of extrudes, revolves, cuts, etc. So it's working on that now. Okay, so it's saying, what do you want me to recognize? And I'm saying, yeah, look for extrudes, revolves, holes, all those are fine. And then we'll let it figure out what it can do. So you can see it first recognized that hexagonal shape, it extruded that, then it extruded or did a revolve for this tapered at the end, and then it did a revolve that were a couple of those in. So there's the extrude for the hexagonal, revolve for the bottom tapered thread, a revolve for the top fitting, a chamfer to kind of knock off these edges of the corners, and then 2 fillets. So it did a great job of recognizing features. So now I've gone from a more generic 3D body to a full SolidWorks part that I could now save as my own. But again, we're just kind of showing you examples of how to get parts. You can find these, so these are if you have specific products that you want, like I knew I was using a Parker fitting, or I was also looking earlier at some Parker valves, so electronic valves. Earlier in the term I showed you an assembly that I created with a programmable logic controller trainer that had a bunch of electronic devices from Rockwell. And so I had models for all those that I'd gotten off of their website. Another useful site are some of the more open source or user created models. So Grabcat is one of those. Earlier this month I was working on a water system and I needed a bulkhead fitting model. So I don't remember if it was from Grabcat that I got it or somewhere else. But for example, you can just type in bulkhead fitting, and here you can see it came up with a bunch of different types. So this is pretty close to what I would be looking for. This is kind of, this one looks like it's a smaller 1/2 inch one. So any of these I can go in and take a look at it. This one looks pretty good, like what I'd like, but if I look down under the formats, it's not a SolidWorks native one, so it's a step file. So if I go and look at it, we can download this file and open it. We'll see again that it probably won't have features, but it will have solid bodies that might work. So if I come back and look at my SolidWorks, and you can see that would definitely work if I didn't need to edit it. Once again, if I look over in the feature tree, it's just solid bodies, not features. So I could do feature recognition again, but this would probably work for what I needed actually for the project I was working on. So this would have been fine to use a non-native SolidWorks file, or I could just keep looking down at that, looking at other Grabcat options. This one here looks like does have SolidWorks, although it's a smaller diameter than I need. Maybe that one, or this one here, would again looks pretty close, and it has a SolidWorks native format. Okay, so I hope that's helpful. You can just search anytime you're looking for a part. I'd recommend, well, McMastercom I've shown you is a great resource for any mechanical hardware, gears, tubing, all kinds of stuff. And then if you're working on a more specific product, look at that manufacturer's website. Do they have models for it? Maybe they have native SolidWorks models. That'll make it really easy for you. But even if they don't, they probably have some 3D model available to you. But let's say worst case, they don't have a 3D model available to you. Then you're either going to need to model the part yourself using a set of calipers or whatever measurement tools you need to get dimensions off it. Or almost every manufacturer, even if they don't have a 3D model, they'll at least have a 2-dimensional drawing with dimensions on it that you could recreate the part from. For example, let's think about that bulkhead fitting again that I was talking about. Made by a company called Banjo. So if I look for Banjo bulkhead fitting, let's see. I remember the company I bought them from. I think this is it. Yeah, okay, so here's a bunch of different types of bulkhead fittings. And if I come in and look at them, so here's the parts. I think I was looking for 1.5 inch bulkhead fitting. And so if I scroll down, they don't have a three-dimensional model, it doesn't look like. But I could look at the catalog page where there may be dimensions on there. And not really any dimensions on the catalog page, so I'm going to go back and look again at the PDF drawing. Okay, so yeah, here now there's a drawing that, again, it's two-dimensional, so it's going to take me a fair amount of work to recreate this part. But based on these views and the dimensions they give, I could model this part myself now in SolidWorks. Okay, so hopefully you'll be able to find a native SolidWorks part for a lot of common off-the-shelf parts that you're going to use. If not, we'll be back to using your part modeling skills that you've developed so far, but this can be a really useful way to save time when you're working with either manufactured parts or common hardware. Hope that's helpful. Let's move on to our next topic, where we're going to look at using some of these parts in patterns within an assembly. See you in the next video.